That's a lot of gas. Next, we're going to create some mysterious fog with something very cold.
Experiment 7, dry ice sublimation. We are exploring how solids can turn directly into gas without melting first.
Warning, always use gloves. You need dry ice, tongs, and a bowl of warm water for this effect.
Dry ice is frozen carbon dioxide. It is extremely cold, much colder than regular ice from your freezer.
When we drop it into warm water, it skips the liquid phase and goes straight to gas. Watch this. The warm water speeds up the process of sublimation, creating a thick, dramatic fog that stays low to the ground.
It looks like a movie set. The fog is actually tiny droplets of water vapor carried by the escaping gas.
Listen to that sound. The gas escaping quickly causes the metal to vibrate, creating a high-pitched screaming noise.
Eventually, the solid disappears completely, leaving no puddle behind. That is the definition of sublimation in action. Sublimation is when a substance changes from a solid state directly to a gaseous state, bypassing the liquid state. Cold science is cool, but now let's turn up the heat with some colorful chemical fire. Experiment 13, green fire. We are using boric acid to change the color of a flame safely. Warning, fire is dangerous. You need boric acid, high percentage alcohol, and a heat-resistant ceramic or metal bowl.
Place a small amount of boric acid in the dish. This compound is often used in household products but has cool properties. Look, add enough alcohol to make a small puddle. The alcohol is the fuel, while the boric acid provides the color.
When we light it, the flame starts out blue but quickly turns a haunting, brilliant shade of green. The heat excites the electrons in the boron atoms, causing them to release energy in the form of green light.
This is exactly how fireworks are made. Different chemicals produce different colors when they are burned in the sky.
Always have a fire extinguisher or water nearby. Once the alcohol is gone, the flame vanishes, leaving the powder behind.
Every element has a unique emission spectrum. Boron always glows green, while copper might glow blue or green too. That was a big mess to clean. But we are only halfway through our 20 experiments today. Experiment 11, the lava lamp. We are using density and gas to create a mesmerizing visual effect. Grab a tall jar, some vegetable oil, water, food coloring, and a few fizzy antacid tablets like Alka-Seltzer. Fill most of the jar with oil first. Oil is less dense than water, so it will float on top. Add a bit of water. Watch as it sinks through the oil and forms a distinct layer at the very bottom. Add your food coloring. The drops will pass through the oil and only mix with the water at the bottom.
Now, drop in a piece of the fizzy tablet. It will sink to the bottom and start reacting with the water.
The tablet creates carbon dioxide bubbles that hitch a ride on the colored water, lifting it through the oil. When the bubble pops at the top, the water sinks back down. It's a continuous cycle of rising and falling.
Density is why the oil and water don't mix. The gas bubbles change the density of the water temporarily.
This experiment is completely safe for children. It helps kids learn how acetic acid in vinegar spectacularly dissolves eggshells.
Step 1. Prepare a large plastic or glass jar big enough for the egg, a bottle of white vinegar, and 1 raw egg.
Step 2. Place the egg inside the jar, doing it gently so the egg does not break.
Pour the vinegar into the jar, leaving about 1 centimeter of space at the top. Then put the lid on, but do not tighten it so that gas can escape to the outside. You will immediately see small bubbles forming. This is the chemical reaction starting to work on the shell. Step 3, leave the jar for 3 to 4 days. Patience is key to seeing the magic happen. Over the next few days, the acetic acid will continue to break down the calcium carbonate in the shell. After that, you take the egg out and rinse it gently under clean water. And you have seen the eggshell has miraculously disappeared, leaving only the soft inner membrane. It is very simple, right? The egg is now bouncy and translucent, almost like a little ball. You can do it right at home, so you can observe it day by day and learn about science.
So relaxing to watch. Next, we are going to make something very cold and very solid melt away.
Experiment 12, melting ice with salt. We are observing how salt lowers the freezing point of water. You'll need a large block of ice, a tray, common table salt, and some liquid food coloring in droppers.
Sprinkle salt on the ice. The salt forces the ice to melt even if the temperature is still below freezing. Now, add the dye. The colored water will flow into the tiny cracks and tunnels the salt has carved.
Look at those beautiful, deep ravines. The salt melts the ice faster in specific spots, creating a miniature frozen landscape.
This is why we put salt on roads in the winter. It turns the dangerous ice back into harmless liquid water. A single large grain of salt can tunnel all the way through a small ice cube in just minutes.
The ice is disappearing before our eyes, transformed by a simple kitchen ingredient into a work of art.
Freezing point depression is the process where adding a solute like salt lowers the temperature at which water freezes.
Hello everyone. Let's explore the plant light-seeking experiment to see the cleverness of plants.
Preparation: a small cardboard box, cardboard dividers, a small bean plant, and tape. Create a maze inside the box using cardboard dividers and make a small hole at the top of the box. Place the small bean plant at the bottom of the maze, then close the lid so light only enters through the hole.
Water it fully every day and wait to see how the bean plant grows in the darkness.
After 1 week, open the box and observe the growth direction of your small bean plant.
The result is that the bean plant found its own way through the maze to reach the sunlight. Plants tend to grow toward light sources thanks to the effect of growth-stimulating hormones.
Light is the essential energy source for plants to perform photosynthesis and sustain life.
The experiment helps us understand the adaptability and natural reflexes of plants.
Hello, kids. Today we are going to conduct a very special scientific experiment called the dancing popcorn. First, let's prepare our ingredients: water, vinegar, baking soda, popcorn kernels, and a glass jar. Start by pouring water into half of the glass jar, and then add 2 tablespoons of baking soda.
Stir the mixture well so that the baking soda dissolves completely into the water.
Next, we will drop a small handful of popcorn kernels into our prepared mixture. Now, carefully and slowly pour the vinegar into the jar and watch what happens next.
Look closely. Carbon dioxide bubbles are being created from the reaction between the vinegar and baking soda.
These carbon dioxide bubbles attach to the popcorn kernels and act like little life jackets, lifting them up. The bubbles pop at the surface, making the kernels sink before they catch more bubbles and rise again.
Don't bounce it too hard or it will pop. Now, let's blow up some balloons without using our lungs. Experiment 6, self-inflating balloon. We will use the power of yeast to blow up this balloon for us. You'll need a bottle, warm water, a packet of yeast, some sugar, and a sturdy latex balloon.
Mix the yeast and sugar into the warm water. The sugar is food for the yeast to start working.
Shake it gently The yeast is a living organism that will wake up and start eating the sugar immediately.
Quickly stretch the balloon over the top. Make sure there is a tight seal so no air can escape.
As the yeast eats the sugar, it breathes out carbon dioxide gas. This gas fills the bottle and the balloon. The bubbles you see in the water are evidence of the yeast being active and productive. Science is alive.
After a while, the balloon is completely full. This is the same process that makes bread rise in the oven.
Fermentation is the biological process where organisms like yeast convert sugar into gas. It's essential for many foods.
Hello, everyone. Let's explore the bone softening experiment to understand the importance of calcium.
Preparation: a clean chicken bone, a glass jar, and a bottle of pure white vinegar. First, check the initial hardness of the chicken bone and try to bend it to see what happens.
Place the chicken bone into the glass jar, then pour in vinegar until the bone is completely submerged. Leave the bone soaking in vinegar for about 1 week, then take it out and rinse it with cold water. Now, try bending the chicken bone one more time and observe the amazing change. The result is that the originally hard chicken bone has become flexible and easy to bend.
The acetic acid in vinegar dissolved the calcium minerals that gave the bone its hardness.
When the necessary calcium is lost, only the organic material remains, making the bone soft and flexible.
This experiment reminds us to get enough calcium to keep our bones strong and healthy.
Science is delicious. Now, let's move from the kitchen to something a bit more rubbery and strange. Experiment 5, the disappearing eggshell. We are going to turn a hard-boiled or raw egg into a rubbery ball. All you need is 1 egg, a glass container, and enough white vinegar to completely submerge the egg.
Place the egg in the glass carefully. Be gentle so you don't crack the shell before the experiment even begins.
Pour the vinegar over the egg. You will immediately see tiny bubbles forming all over the surface of the shell.
Those bubbles are carbon dioxide. The acetic acid in the vinegar is already starting to dissolve the calcium carbonate shell. Leave it for 24 to 48 hours. The shell will vanish.
The egg is now soft and squishy. It feels like a rubber ball because the hard shell is gone. Look how the light passes through it. You can see the yolk floating inside the translucent, rubbery membrane. The acid reacts with the calcium in the shell, turning it into a gas and leaving the rest of the egg intact.